All right, part 2, start with number 13. You can see I've already tried it, and I realize that formula is a big old typo. Here's our formula. So it says, what's the 11th term? So that's what we're trying to find. We're trying to find the 11th term. That's what that stands for. This represents our first term, so that's our 3. Notice R, what is that? Well, what times 3 is 9? 3. What times 9 is 27? 3. What times 27 is 81? 3. So that's where we get our R from. And then N is the 11th term, so we're going to go 11 minus 1. So what we're looking for is going to equal 3 times, what is this? 3 to the 10th. So we really could find just 3 to the 11th power because that's what's there. So I'm going to turn this on. And so here we go. 3 to the 11th power. So we would get 177,147. Good luck doing that one without the calculator. All right, let's go on to 14. Given cosine is 35 over 37. Well, that would mean if we were to draw the drawing, I'm getting ahead of myself, you spin your spinner less than 90, greater than 0, so it's somewhere in the first quadrant. So that means my adjacent side would be 35. My hypotenuse would be 37. And they're asking which of the following are other trigonometric ratios. So any one of these could be true. Now what we should do is find this other side, and there's no easy way of going about it, but I'm going to put an x in there. 35 squared plus x squared equals 37 squared. So we're going to go 35 squared, and we're going to go 37 squared, and I'm going to do this a little different. All right, so we would get 1,369 minus, I must have hit a button wrong somewhere, 1,225, we get 144. So if I subtracted this, I would end up getting x squared equals 144. And that's very nice because you can see that's a 12. So that means my opposite side is my 12. My theta is right here. Remember that. It's our reference angle. So now, sine, opposite over hypotenuse. Ding, 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 ding. Sine, opposite over hypotenuse. No. Cosecant. Now wait a minute, what's cosecant the reciprocal of? Sine. And if we knew that sine is 12 over 37, this would have to be 37 over 12. So that's an eh. Now cotangent is the reciprocal of tangent. Tangent is opposite over adjacent. So if we find this, opposite, 12 over adjacent, which is 35, and we flipped it, would we get this? Yes. So that's our second answer that works. All right, number 15 requires a good drawing and the ability to read these words. So here we go. The sun is shining. Creates a 27-degree angle to the ground. That's important. From Eliza's head. Now, forgive me for my lack of artistic ability, but here's the ground, and here's the sun. And the sun rays going like this, and so it creates a 27-degree angle with the ground. So here's my 27-degree angle, not with her head, but with the ground. And it casts a 120-inch shadow. Now where's the shadow? Along the ground. So that means this is 120 inches. This is a fancy way of just giving you a right triangle. It says, how tall is Eliza? Well, that's our x. Notice this is our opposite side to the 27. This is our adjacent. And so we would say, aha, tangent, because so, ka, toa, we want the opposite and the adjacent. So it's tangent of 27 degrees equals how tall she is over 120 inches. Take my calculator, make sure you are in degree mode, which I am. So I'm going to go tangent of 27 degrees, and I have to multiply that by 120. So times 120, and she is approximately 61.14 inches tall, around 5 feet. Okay, number 16, find the exact value. Now, you can use your calculator to check, but I'm going to require that you show your work. That's what we've been teaching you. So 30 degrees. Spin your spinner up 30. There's my 30. Draw back to the X, never back to the Y. I don't have any sides, exactly. So you can call that a 1, and if that's a 30, 90, 60, this would have to be 2. This has to be the square root of 3, your old 30, 60, 90 rules. What's tangent? Opposite over adjacent. So tangent of 30 degrees would equal opposite over adjacent. And then I assume we should get the square root out of the denominator. So this is the answer if they're really particular about the square root in the denominator. This is the answer if they're not. How would you find cotangent? Well, just flip this. So that'd be the square root of 3. Just throw that in for free. Okay. An angle has a reference angle of 37 degrees in the second quadrant. So that's talking over here. Try to get my drawing somewhat accurate. What is one positive and one negative coterminal angle? Well, that means you spin it and it ends up at the same spot. So I'm going to go with the negative first. So that's a negative 180 plus the 37, so that'd be negative 217 degrees. There's the positive one. Excuse me, the negative one. What's the positive one? Well, I flip it that far, which is how far? Well, if I think about it, this plus this has to be 180, so it'd be 143. But then I need to keep going another 360. So it's 143 plus one more revolution, and that would be 503 degrees. So there's your answer for number 17 and how to do it. Number 18, find the remaining 5 trigonometric functions in the third quadrant. Well, if tangent is by definition opposite over adjacent, then I could draw my drawing with some accuracy. This isn't drawn to scale at all, but if that's my reference angle, and that would mean this is my opposite side, and this is my, whoops, I'm in the wrong quadrant. So forget that. It says third quadrant. Needs to be over here. We'll just make a quick adjustment here. Forget that little drawing. Here's my reference angle. Opposite is 21. That'd be negative, and because it's down. And my adjacent would be negative 20. See, a negative over a negative gives me my positive, so be careful with those. So I'd have to figure out my hypotenuse by going a squared plus b squared equals my hypotenuse squared. So that's 400 plus 441 equals x squared. So that's 841 equals x squared. So you take the square root, and amazingly it works out to 29. Remember, your hypotenuse is never negative. So what are our other functions? Well, sine of this situation would be opposite over hypotenuse. So cosecant would be the flip. What is cosine? Cosine by definition is adjacent over hypotenuse. So that's negative 20 over 29. The reciprocal is secant, so that'd be negative 29 over 20. Now we already know tangent is given to us. It's 21 over 20. So cotangent would be 20 over 21. There you go. Okay, on to parabolas. What is the equation of parabola with vertex 2, 2? This is where I tried teaching you guys every picture tells a story. So take your time and draw a picture. So 2, 2 is right here. Directrix, that means it's a vertical line at x equals 4, but it tells me a whole lot more than that. I taught you guys this is the soil, so your tulip blossoms away from the soil, but it also tells us this space, which is C, is 2. From this picture, I know a whole lot. It's an x equals ay squared kind. I know that a has to be negative because of our Pac-Man rule. It's chomping up points in the negative direction of x. And I also know that c is 2 from this. That's where I fuse this formula, which is given to you on your formula sheet, a equals 1 over 4c, and I go 1 over 4 times 2, and I get 1/8. Now, if I'm not really thinking about that clue, I'm going to miss it. I got to put that negative in myself. Now, if the vertex is 2, 2, and this is my foundational kind of like parent function, I'm going to first start by putting the negative 1/8 where it belongs. But then I'm going to remember my y value went up 2, and my y value is here. So I'm going to go y minus 2. And then if I go right 2, and it's an x equals kind, I'm going to put plus 2. And there we have it. Let me pause this a second. Number 20. If the equation of a parabola is find the vertex, focus, directrix. So now we have the equation. We just got to make sense of it. First thing we're going to do is find the vertex. Where's that darn vertex? Again, like the previous problem. See that right there? Y minus 2. That, if it's in the parentheses, we got to go opposite land. Minus 2 means up 2. And then this goes directly with this. So that means right 1, which means 1, 2. So 1, 2. Now, I know it's negative, so it's going to be this way, just like this. And so now I got to find the vertex. Did it. It's right there. Focus and directrix, I got to find this letter C. I can ignore the negative. There's my A. 1/8 equals 1 over 4c. Now, why can I ignore the negative? Because I know c is a distance. And I can just look at this. 4 times what is 8? That would be 2. So I need to go 2 units backwards. Remember, the tulip blossoms away from the soil. So that's x equals 3. And now I need to go 2 units to the left to find my pistil, or my focus, which would be negative 1, 2. So there's my focus, there's my directrix, there's my vertex. There we go. What are the center and radius of the circle with the equation? All right, so here it comes. This is where your completing of the square technique is going to be pretty valuable. Now I'm going to subtract the 20 from both sides. That's going to play into the radius. Take half and square it, 4. But then I have to add 4 here. Take half of that, 8, square it, 64. But I got to add a 64 over here. What does this turn into? X minus 2 squared. What does this turn into? Y plus 8 squared equals 68 minus this would be 48. So what's the center? That'd be right 2, down 8. How do I find my radius? Remember, this is always equal to r squared. So r squared equals 48. Again, I don't know if they're going to break this down or not, but this could be the answer. But notice, 16 goes into that 3 times. So they might want it broken down as far as possible. So there's my radius. Next problem, 22. So let's graph it. Well, what is it? It's an ellipse. Notice there's a plus. X squared, y squared with different denominators equals 1. So that means this is my a squared, which means if I take the square root, I get 5. That's how far I travel up and down the y-axis. 1, 2, 3, 4, 5. And then b squared is 16. So take the square root, so I get b is 4. 1, 2, 3, 4. It's going to look like a circle, but it isn't. And it does not say find the focus or anything like that. Sorry about that. Looks a little wonky, but that's it. All right, last problem for this portion. Write the equation of a hyperbola. Remember, a hyperbola is very similar to an ellipse. It's just that that needs to be a minus. Whoops, sorry. That needs to be a minus. So let's go with the picture first. Foci is 0, negative 6. 1, 2, 3, 4, 5, 6. 0, 6. 1, 2, 3, 4, 5, 6. Those are the foci. The vertices are 0, 2 and 0, negative 2. That means it's going like this, which is massively important because now we know, because it's a Pac-Man going up and down, we know it's a y squared over a squared minus x squared over b squared equals 1. Now notice the distance between the center and the vertex is a. So a is 2. All we got to do is square it and put it there. So that's y squared over 4. Minus, we got to find b squared. Well, we know what this is. That's 6. That's our c. The center to the focus is c. So, we know from the formula a squared plus b squared equals c squared. Again, this formula is given to you in your formula sheet. A squared is 4. B squared we're looking for. If c is 6 and we square it, it's 36. Subtract 4, we get b squared is 32. And that would go right there. There we go. That ends part 2.